Well, hey y'all. Hey, I had one of our colleagues ask about making braces and jigs and things like that. I figured, well, I'm going to be doing this today, so I'll touch on how I go about making fixed style braces like this one here. Actually, this is a factory original from like the 1940s from King, and it was for a job that I'm doing right now. That interesting thing there, yes, it is what you think it is. But anyway, I have to make some replacement braces because with all the alterations I've done on this valve section, I have some braces that are no longer usable, and I need braces that fit exact. So in the case of like this valve section, I have a spacer brace that has to go between the lower third slide and the lower first slide, and then I have another one that has to go between the upper third slide and the number 2 slide. So the way I go about it first is I get all of the pertinent geometry off of the original brace, diameters and whatnot. I have already made my flanges. They've just been cut out. They're just blanks. They're .025 thick. So now I have figured out what I've got going on here. I go via this dimension between these two, which I've written over here. 1.190 is the overall span, so we have to remove or subtract the thickness of the flanges, which is 50 thousandths, and so that gives us 1.140, approximately, give or take. Anyway, so now that tells us what our brace length is, and then we've also worked out the dimensions of the girdle and the ends of that spanner. And so we establish those, we machine those points, and then we just use a mill bastard and connect the dots. You don't have to start cutting tapers and silly stuff like that. This is a brace, for crying out loud. But I will machine a pin on the ends. Okay, the farthest end of the rod that's being machined. After I've got all the dimensions and everything laid out, then I will turn down well, I've already left enough material there, but I'll turn down a pin that's approximately 0.50 freedom units into, and then it'll probably be about a ½ inch long, maybe even a little longer. But the flanges will then, they're punched, they're reamed so that they fit snugly. They've had their radiuses put into them because, I've already annealed them and everything so that they can be fitted. You want them to have the radius so that they lay up against these tubes nicely. And then you snugly pull that over. Silver solder at the base of the pin will pull through, provided everything is clean and it's been fluxed well. Capillary action will draw it in, and it will actually backfill even the areas on the ends. You will have gaps because these are machined flat. I don't mill radiuses in them. But you can pull, the silver solder will pull in and it will draw around and it will actually fill those side voids, provided you give it enough heat and do it right with some care. But you'll end up with a really nice end result. But not really super complicated. But it does take a little bit of skill, but with practice you can knock these out pretty quick. Anyway, that's kind of how I go about it. I don't really do a whole lot with any kind of jigs. I mean, I will use a third hand to hold things. That's a third hand for those of you who are new to this line of work. But that just will hold things so that you can silver solder it neatly. It's best to use oxyacetylene if you have it. But you can use your acetylene, like your Gauss or your Prestolite or even a Smith torch to do the silver soldering on this. But you got to get things really, really hot, but don't melt anything. Okay. I've made our cross member there, our bridging part, and the flanges. Got these over here. And so as you can see, it's been machined with a pin on the ends, and this is what I pretty much mean by what I was talking about. Now you can see, yes, there are gaps on the sides, and when we silver solder this, those should fill in pretty nicely and be very respectable. So I will proceed on with fluxing, and we'll hold this probably in a third hand, and then just heat it up, silver solder it, and then flip it around, hold it by the other pin, and heat up the other side, and do the same. Then we can see what the end results are. So here you go. I'm back. I got the braces machined, and I got the flanges silver soldered on and cleaned up. They've just been pickled and wire brushed is all, just to get the idea across. They do need some cleanup. There'll be a little bit of polishing, a little sanding here and there. But as you can see, the pins, they've been brazed through, silver solder. And same with the short one. Knock that out. And if you look closely, you can see how the braze fills through and closes up the gaps, so they're nice and clean, uniform, just like the originals. So there you have it. Now all I have to do with this is grind those pins off, square up the edges of the flanges, and do a little bit of sanding and polishing on those. And they should pretty much slip right in. Let's see. Yeah, that should be the ticket, but I won't know until I get the braces ground up. They might need a little bit of dressing, a little bit here and there, but that's pretty much what I do when I make these spacer braces that are not adjustable and they have to fit absolutely dead on the money. So yeah, there you go. Well, it didn't take a horrible amount of time, a little bit longer than I wanted to, too many distractions. But anyway, we got the flanges radiused and punched and then reamed. I turned the bridging sections of the braces and got those in the ballpark. They're pretty close, but they should fit my needs quite nicely. So I'll show you what we got going on here. You can see that the pins were pushed through. The holes that we punched in the flanges were done prior to radius of the flange, and then once they were radiused to match the outside slide tubes, then I used just a little reamer and went and reamed them through until they were a snug fit on their pins, and then they were just pressed on. The silver solder was then applied. You know, they were fluxed liberally. Flux is cheap, and it will get the job done. If you don't get enough flux on there, you're not going to get the best results. Too many problems can arise. So don't be stingy. Anyway, everything was fluxed. It was all pressed together again, and then silver solder was applied at the base of the pin and flooded liberally, but not too much. I did that on one, just a little teeny too much, but that's okay. But as you can see, the flange is filled and has a nice, clean corner in there. No gaps or anything like that. Relatively square, but no different than the original, which was maybe a little sloppier. Anyway, so next step is to grind off the pins. I'll just use a parting disc on my Dremel probably. And then everything cleaned up, I'll use a safety file around the edges of the flanges to square them up nicely. And then if I have to make any other adjustments, like grinding a little tiny bit out of the undersides of the flanges, whatever, if I need a little extra room, I can do that. But for the most part, these should slip right into place because they are the right geometry. We'll see. Anyway, that's how I go about making not adjustable spacer braces, and you know, you can adjust to what you have in your shop in the way of tooling and equipment and your skill sets. Practice, and you get pretty good at it after a while, and then you look at it, it's no big deal. So there you go. Y'all have a good day.